Hey, hi, Rajan this side. Welcome to the channel. So we have started a 100-question DSA series to crack any coding interview. So in this series, we will cover each and every data structure and algorithm such as array, matrix, string, stack, skew, dequeue, linked list, tree graph, DP, greedy, beat manipulation, and all. Right. So in this series, we will cover each and every possible questions that could be asked in an interview. Right. So we have started with array first. So the first problem in the array which we are going to solve is trapping rainwater problem. So in this problem you will be given an array that represents the height of each bar, right? For example, here 0, 1, 0, 2. See, the height of first bar is 0, no height. The height of second bar is 1, the height of third bar is again 0, no height. The height of fourth bar is 2, see the height is 2, right? So these are the height of the bars, and the width of each bar is 1. The width of each bar is 1, and in this problem we have to calculate how much water that can be trapped if it rains, right? So if it rains, if you see, these blue colors are the water trapped inside, right? So here in this test case, if you see, the total water trapped is 1 into 1. So this is one of the portion of the water that is trapped. So here is the area is 1 plus here again the width is 1, height is again 1, 1 plus here see the width is 1 but the height is 2 for this area, right? So this is the water trapped. So here the 2 into 1 2 plus again 1 into 1 1 plus again 1 into 1 1. So the total water trapped is 6, right? So yeah, I hope you understand this problem. So to solve this problem, what we will do, if you think of each bar, let's say there is a bar here, right? So this is the original height of the bar, right? This is the original height of the bar. If you think of this bar, the water above it, so whatever height that is trapped here, it completely depends on the minimum of the highest bar on the left side and highest bar on the right side, right? For example, let's say this is my bar, right? So let's say on the left side the maximum bar is, let's take this height is 6, and on the right side let's say the maximum height of the bar is 5. See how much water that can be trapped. The water that can be trapped is this much, right? So see, we are taking the minimum of maximum height on the left side and the height on the right side. So your total water, let's say this is the ith bar, the total water that would be stored on the ith bar is equal to minimum of left max of I, comma right max of I. So this left max and right max essentially tells you what is the maximum bar of any height on the left side, and similarly right max will tell you the maximum bar of any like the maximum height of any bar on the right side. Just take a minimum of that, and so this is the height up to which your water can be trapped, but your original height is also h of I, right? H of I is the original height. So the total water that can be trapped is the minimum of that minus your h of I, height of I. And we know that the width is 1, so into 1 doesn't matter. So this is the water that would be trapped on the ith bar. And similarly we can traverse through each of these bars from 0 to n, 0 to n minus 1, and then we can calculate the water that is trapped on the ith bar, and then like we can take the summation of each one of them, right? So the reason why we are taking the minimum of left max and right max height, because if you see here, this is the left max is 6, height 6, and the right max is height 5, right? We cannot so the water cannot be trapped beyond it, because if the water is so if the water drops here, it will spill over, right? It will spill over. So the maximum height up to which the water can be trapped is 5, and which is the minimum among these two. Otherwise it will spill over from this height, right? Beyond this height it will spill over. So the maximum possible height is minimum of these two. So yeah, this is all about the explanation, and in order to implement the left max and right max, what we can do, we can create two vectors. So your left max of I would essentially stores the maximum height from index 0 to I, right? And similarly, your right max of I would tell you the maximum height from index I to n minus 1, right? So this is your left max and right max, and so we can kind of follow the similar approach how we kind of build a prefix array and suffix array, right? So yeah, this is all about the explanation. Now let's look at the code. Here is the code of trapping rainwater problem. So you will be given a height array that represents the height of each bar. So first face the length and just check if there is no bar. If there is, like, if the length is 0 means there is no bar, so there is no water trapped, so return 0. Now the next step is to build left max and right max, and we know what is left max. So left max of I essentially tells you the highest bar from index 0 to I. So the way we build it is same as the how we build prefix array. So left max of 0 is height of 0, and from index 1 onwards your left max of I is going to be maximum of previous left max comma current height, right? And similarly we build the right max. So the way we build is how we build the suffix array. So the right max of n minus 1 is going to be height of n minus 1, right? And from index n minus 2 up till 0, your right max of I is going to be the next right max of I plus 1 comma current height, right? So till here your left max and right max is built. Now the job is easy. We can just calculate the trapped rainwater for each of the bars. So we will start from index 0 to n, right? So we'll go through each and every possible bars. Now in the current bar, so let's say I is my current bar. So the water that would be trapped here is minimum of left max and right max minus height of I, right? So please check out the explanation part. I have explained there how it works, and just add it to the total trapped water, and at the end return the trapped water, right? Alright, so yeah, if you find the video helpful, please like, share and subscribe to my channel, and I'll be posting next video in this DSA series very soon, so stay tuned. Thanks.